EVM object format, or EOF, is a set of proposed changes for the Ethereum blockchain. They may have a significant impact on the Ethereum ecosystem and smart contract development. If you are a smart contract developer or interested in learning about EVM's upcoming changes, stay with us. Welcome to PEEPanEIP episode 121. I'm Pooja Ranjan, and I'm joined by a popular Ethereum client developer to talk about a bunch of proposals for EVM improvement with a future upgrade. To learn about EOF and Mega we are joined by Danno Ferrin, an Ethereum client developer with Hyperledger Besu. Welcome, Danno.
Hello, good to be here.
Let's begin our first section, Meet the Guest, where I request our guests to briefly talk about their professional background, how they joined Ethereum, and anything else they would like to share to inspire our listeners to join the Ethereum community.
Cool. So yeah, I came into Ethereum through interest in blockchain, and I came through interest in blockchain through Bitcoin. In a previous life, I was a desktop application developer. One job I had and I'd left, I found this really interesting visual analysis tool called ygraph, which has a lot of graph layout tools. And I thought it was really neat. JavaFX was the library that made laying these things out really neat. And I needed an application that really showed an interesting graph. And so this is about the time when Bitcoin first hit $1,000. And I looked at the Bitcoin spec, learned about how this UTXO thing kind of made an acyclic directed graph, and thought that would be really interesting to visualize at scale. So I started out by, creating an app that visualized that. And I happened to stumble right into some exciting things happening with Mt. Gox. This is after they'd gone bankrupt. And then all their Mt. Gox things started doing this triangle split of everything was splitting twice and going down. So that took me down a rabbit hole. Didn't last too long. I initially thought about doing blockchain forensics, but I thought it was a little creepy. Having been on both sides of the forensic side, I agree it's creepy no matter which side you're doing it on. Some people are cool with that. I decided it wasn't for me though. So I thought I'd try and get out of blockchain, and I thought, I know, I'll go to Google. That'll get it out of my system. And it worked for about 2.5 years. And then the way Google works is, you often switch projects, and your project's finished, you need to find another one. And right at this time is one of the recruiters from Consensus called me up and said, hey, have you been following the Ethereum stuff? And even though I've been trying to get out of Ethereum, I've been following all the stuff that's been happening with like the Shanghai attacks and with the DAO. And I was really interested in a lot of the stuff going on. I just didn't feel like, I could give up Google. But when this recruiter called him and said, hey, you can be a core dev on what was then called the Pantheon project and contribute to it, it was just too enticing for me. So I quit my comfortable job at Google and I went full crypto. And that was about almost 5 years ago, over 5 years ago now, that I joined Consensus. I stayed there for almost 3 years, did a brief stopover in Reddit to work on some of their community point stuff, but then I came right back. And right now I'm working at Swirlds Labs, which is a company that does a lot of the development for Hedera. And I spend almost all of my time working on the EVM stuff within Hedera, and I contribute to the basic client to keep all of their EVM stuff up to date, and as well as pushing the future of the EVM. So yeah, I still, I've worked in Besu for almost 5 years, just with different employers, still working on getting various parts of it. My current focus is on the EVM. It's kind of in my opinion, it's a little bit neglected because there's a lot more shiny objects that have a lot bigger issues. But I think, if we keep neglecting it, it's gonna be one of those things that kind of sneaks up on us. So that's why I've had a lot of interest in a lot of these proposals to try and make the EVM better. And I think EOF is kind of a synthesis of the best ideas that's going to move the EVM forward in the direction it needs to go.
Pretty interesting. Like from forensic, Google, Consensus, Ethereum, Reddit, back to Ethereum, and now contributing to EVM, you have quite a lot with you to share with Ethereum community. Thank you so much for all the work you have done in this space so far. I look forward to see more on that. Before we dive into today's talk, I want to share that EOF was originally proposed by Team Epsilon, and EIP 3541 reject new contract code starting with 0xEF byte is already deployed on the mainnet with an earlier Ethereum upgrade. So if you missed the talk on EIP 3541 with Team Epsilon, please check out episode 36 on PEEPanEIP at Ethereum Cat Herders YouTube and podcast. Well, let's move on with today's talk. Without further ado, let's peep in.
All right. So It's EVM object format. I always want to call it Ethereum object format, but it's actually EVM object. Or if you want to go another layer, it's the Ethereum virtual machine object format, which I've seen some people actually use when they decompose it completely. But I just call it EOF. It's a big collection of a lot of different EIPs that work together that really don't stand alone, although they do a lot of different things. But the first thing I want to talk about is who's working on EOF. As Pooja mentioned earlier, this is the brainchild of Team Epsilon. Epsilon is an Ethereum Foundation funded team, and they're focusing on EVM improvements. In a prior life, they were focused on the eWASM project, where they were going to replace the EVM with an Ethereum version of WASM. They spent a lot of years on it, and it never fully deployed on mainnet because a lot of the work they did proved out that there were some issues with it that didn't quite meet the performance standards they were hoping for. And they tried a lot. They know all the great reasons why it's not quite going to work for Ethereum with all the constraints. So since then, they've reoriented and they've been focused entirely on the EVM. And EOF is really the synthesis of a lot of the work and a lot of the knowledge that they have as far as what's going to work in the EVM and what's not, and what's something that we could move forward to, and things that are just not going to work for Ethereum. The second group of people that have come in recently in the past year or two have been the execution clients, mostly represented by three big clients, Geth, Besu, and Nevermind, who've been working with this with the Team Epsilon on the EVM channel. And we have calls every other week to try and build up and actually implement the spec that we had it. Back around January of this year, we actually had all of these three clients had fully functional versions of a version of the EOF spec called Big EOF. And we were going through fuzzing testing, and we were pretty far along fuzzing. There are just some issues with some of the compiler stuff that I supported pulling it out of Shanghai. And some people had bigger objections with things on some of the other issues that I'll listen. They're now part of what's called the Mega EOF spec. There's another client there listed, EVM1. That is a C++ client written and maintained by Team Epsilon. It's a sort of client that is suitable for inclusion as a library in just about any piece of code you'd want to write. So there is a library that you can put an EVM with all these features in anywhere you want it, written and supported by an EF-funded team. The third group that I think is worth mentioning, and this has happened in the past 6 to 8 months, and I think is an important addition to building EOF, is we got the compiler teams calling in and actively contributing and asking for more things and saying, this works for us, this doesn't work for us. Now, when you think about it, for a VM, the compiler teams are the real customers, are the real people who take whatever their high-level language is and compile it down to actual VM code. So to get their input is amazing. And Solidity and Viper have had significant input. A lot of the changes that you'll see and a lot of the changes we're considering are a direct result of some of the things they want to use EOF and to make sure that there's no size regressions or gas regressions, that they can get what they need and it has all the features that they have. And another group that's called in, all our meetings are public for the EVM implementers group. There's a group, I think it's called the S-Store2 project. And this is a group of people who are really excited about using smart contracts as data storage cheaper than offline storage. And this is for stuff like NFTs and other sorts of features where you need to have the data available at all times, but you don't want to necessarily pay the storage fees for it. And they've been there making sure that their concerns and their needs are fulfilled. That some of the opcodes we talked about and some of the solutions are directly to get those needs. So we've been talking with community members, compiler teams, execution clients, and of course, Team Epsilon, the team that came up with the EOF and wrote most of the specs that we're going to talk about today. So it's been a pretty broad base of people working this. This isn't just somebody in their basement coming up with bright ideas. Started out that way, but it's grown to something much more accepted by the community, I think. So going to a bit of the background, why EOF? So I went through all the EIPs and I tried to list all of the unimplemented and unadopted EIPs that are out there. And this is a long list. The stuff on the left is the stuff that's actually active. And the stuff on the right is what's called dormant, or I can't remember exactly what the word is. But these are basically the ones that are have no one maintaining, no one's contributing to anymore. So effectively, they're considered functionally inactive and not being worked on. And I actually ran out of slide space to write all the inactive VMs. And this is even cherry picking some of the EVM stuff there, taking some of the obvious stuff out there that doesn't apply. And from the stuff on the right, everything that is in a darker color is actually addressed by some of the features that are part of EOF. And the stuff in lighter color doesn't quite, taken care of by EOF, like the SIMD might benefit from some EOF features with the immediate arguments. But account versioning, subroutines, data separation, getting rid of stuff like call code and self-destruct, multi-byte functions, procedures, These are all taken care of by some of the EOF proposals in one way or another. So the reason I put this list together is to show that some of these ideas that we're trying to fix in EOF have been around almost since the dawn of the EVM. I mean, when it was written over the weekend, there were some really bright computer sciences people who wrote it, who knew a lot about CS and a lot about what they needed to do with VMs. But in a weekend, they didn't have time to sit and ponder about the 10-year needs of what a rich ecosystem would be. I mean, that would be, they were just worrying about getting something working as soon as possible. So this is, kind of the natural evolution of what success looks like, is some of the problems are much greater than could have been imagined at first. So this is an attempt to solve some of those, success-related problems from the VM. So we've talked about EOF. Other than a collection of EIPs, what is EOF? At its core, EOF is a container format for Ethereum virtual machine code. It's not a redefinition of the bytecode. It's not any fancy reimplementation of the VM. We're just putting things in different places and being deliberate about the way we're naming it. We're taking our code and our data in the VM code. We're putting them in different places. We're putting a header in to talk about all the different places we're putting the code. And we're also including things like requiring that all code that is in the code section be actual valid functioning code. You can't just put garbage in the code section. Now in data, it's not called garbage, it's just called data. But as far as the code, we need it to be real functional code. Now, because of this, the EOF structure fixes a number of EVM evolution problems just by the nature of its existence, of how it's setting things up and the spaces it's preserving for other behaviors. The biggest thing is it allows opcodes with what's called immediate arguments. You're probably familiar with these if you look at the push instructions, all the bytes that follow the argument, or it's called immediate arguments in compiler parlance. So we allow immediate arguments to occur anywhere, not just in push opcodes. And the second thing that I'll go in later, because it's a lot longer list and a lot more esoteric, is it prohibits problematic behaviors within the VM. So if you put in the EOF in the container, you put the code according to the rules, there's lots of problems that you just won't have to deal with if we get everything we want into the EOF. And eventually, we can get there through multiple steps. But probably a question for later, why mega versus big versus small. I'm an advocate of breaking things once and getting it done once and forever. And I think we can get there, but other people have different opinions, and we got to work together as a community to figure out how we're going to get there. So let's quickly talk about, this. I've talked about immediate arguments. Let's talk about a little bit of a story of why immediates are such a big deal. Let's take one of these EIPs. Let's add immediate relative jumps, which is, EIP 615 had a variant of this. So in EOF, we define the E0 instruction as a relative jump. And it takes 2 immediate bytes after it, which form a signed 16-bit integer, kind of like push 2. And that tells you how many jumps forwards or backwards we want to jump from. So over here on the right, we can see, how it would look in EOF for these jumps. Instead of seeing a 65, you would see an E0, and we would go forward 128 bytes. Or if you wanted to go backwards, you'd see an E0, FF80, which 2's complement encoding is 120 bytes behind you. Now, how this would look in legacy code is a bit different. If we were going forward, we would push 2 bytes onto the stack. And so for one, legacy is fixed location. And if we're currently at PC 100, if we want to go forward 128 bytes, really, we would say we want to go to an absolute number 1080. So we would push the destination on there, and then we would jump. And if we want to jump backwards, we would push, backwards and forwards are the same. You just push your final destination, and then you jump. What's interesting is there's a slight, savings in size just from the push operation. And also we can get rid of the jump dest. I mean, this looks easy. How hard could this possibly be? What security problems could we possibly have from this? Well, researchers are clever. And here's the problem to just introducing new immediate bytecodes, a new immediate argument gets in, is it has to do with a jump dest instruction. Existing EVM bytecode does have a validation rule, and that has to do with your jump dests. And what they're saying is that when you do a jump operation, the operation it points to must be a 5B jump dest operation to make sure you're not jumping to points in the code that aren't intended to be entered. So there's a second step in that, and that these jump dest operations cannot be inside of immediate data. And at the time that this rule was made, immediate data only consisted of push operations. So here's an example of what, we take this random bit of EVM code. This may or may not be useful, valid code, but it demonstrates the issues. So we start with a couple of push operations. We push this value, we push that value, push EO11, and then we push 5B61. And then we have another opcode that's not push related, another opcode. And we have an invalid opcode. And then we have another, and this is a known to be, this is actually a valid opcode. And then we have an opcode that's not recognized, so it becomes invalid code. And then we have a couple of data things that look like it could be valid opcode, and then 2 more invalid opcodes. So when the jump dest analysis goes through the EVM, it's going to say that this one is not a valid jump destination, and this one is a valid jump destination. And, lighting issues of it, would code actually look like this? We got to realize that when we do these things, we need to make space for what is possible, not what is practice. Because what is possible is often how hackers, what is possible, but not necessarily good practice is usually where all the good exploits are. So we need to make sure that what is possible is not going to cause problems. So if we add our E0 opcode, what's going to happen is the semantics are going to change. Instead of having in this snippet one valid jump destination and one invalid jump destination, if we put an E0 with 2 valid operations come after it, all of a sudden we have no valid jump destinations in this code. Just by adding a new opcode that takes immediate arguments, there are potential contracts out there that might exist that now have invalid syntax. And you can get around this, with good compiler structures. The Solidity would mostly avoid this because they put all their data at the end, but that's not a guarantee. The compilers might sprinkle their data all over the code in the middle because Verkle Tree might incentivize that because you could put your data in the bits that are going to be loaded. So the incentives, hackers might use it to kind of stealth deploy some contracts they don't want easily analyzed. People might put these patterns in to disrupt decompilers. There's lots of valid reasons to put these in to explore these cases that are not necessarily fitting in the current convention, but are possible within the scope of the EVM. So because it's possible to change the semantics of a contract that's already been deployed, that's why any opcode proposal that's had immediate arguments has been rejected, because of the potential security implications and the space we're taking away from already deployed code. So that brings up another question. How do we evolve the EVM? And generally speaking, I'd say there's 2 ways to do it. There's compatible changes and there's incompatible changes. We do compatible changes to the EVM all the time. Let's say we need to get the blob gas. We just add another blob gas code, it returns the value, doesn't take any immediate arguments, doesn't ruin any other contracts. It doesn't remove any other functionality. That's easy to put in. So it adds new functionality or feature, doesn't change the other stuff. But let's say we want to get rid of self-destruct. Let's say we want to get rid of gas from function calls. That alters functionality that other contracts may depend on. And there may not be an equivalent feature set. Some of the proposals for self-destruct have no alternative for if you want to get rid of your contract. So we're getting rid of feature sets for some of these changes. So getting rid of self-destruct is an incompatible change, but just adding a new random opcode is a compatible change, a new block header, no new block header query opcode. Another thing that we need to be mindful of with compatible and incompatible changes is whether we're making an existing contract bytecode that was valid into invalid code. Now we can take what was invalid code and make it valid. That's perfectly fine. But taking stuff that was invalid and turning into valid code that was valid, making it invalid, you're basically breaking a contract that may or may not have worked. There are risks also in sometimes making invalid. There's tricky things to go on with there. But generally speaking, if we take something you can't do into something you can do, and we'll let you deploy it then, that's generally a compatible change. Another couple of requirements is that you must execute all prior contracts the same. We can't just redefine opcodes and make them do random things. Changing add to multiply would cause havoc everywhere. But if we do it in a way that isolates it, then that wouldn't be such a bad thing. We put add somewhere else and switch them around. One of the final steps of this is that if you're doing a compatible change, it's like a minor version upgrade. It doesn't require a contract version. It doesn't require a major update. It's what's called forwards compatible or backwards compatible, depending upon the scope of the change. But if it's an incompatible change, it's going to break things. And you need to have some way to isolate it and some way to make sure that things still function in the old system, stuff that's been deployed and will continue to work. So we need to make sure, especially in Ethereum, that whatever changes we do, we can always deploy what's been there. So how does EOF interact with the existing Ethereum virtual machine? So one of the big things that's proposed for how we're going to release it on mainnet is that EOF will operate in parallel to legacy EVM smart contracts. They'll look just like smart contracts. You can compose them together. They can call each other. EOF can call EVM, legacy EVM can call EOF, and things will work just fine as if it's just another contract. It'll look the same to a lot of end users. When you call a contract, you won't know if it's EOF or not, unless you do, some very specific things. What the difference between EOF and legacy EVM is in their feature set and in their packaging. The EOF will have packaging talking about what they can do within this, whether the code is, where the data is. And they'll also get some features in EOF, and legacy will have some features. So there'll be a slight feature different, like if you want to self-destruct your contract, you have to use legacy EVM. That is not something that's going to make its way into EOF. It's one obvious example. But apart from those changes, EOF and legacy EVM code are almost exactly the same. They work on operands, they have stacks, they use long-term storage, they use transient storage, they have accounts, they work on message frames. If something reverts, the entire message frame almost never existed, and they use memory and transient memory. Almost all the semantics within the EVM is still the same in EOF packaged EVM code versus legacy packaged EVM code. It's the same system. So here's kind of an abstract architecture looking at the system, and this is how we would have it today. Before we execute the code, we need to do some jump dest analysis, and that's going to give us a list of valid jump destinations. Then we go into actually executing the code. So there's a loop that operates the opcodes in the message frame, goes through and operates that. And then on the right, we have a representation of the selection of operations that this opcode loop might have access to. So what happens today when we add a new opcode is all we just do is just add more operations to the list of operations that might be executed, like push 0 just becomes another operation on that list. I think the new one coming in Cancun is going to be the blob gas fee. That is just another operation. The loop stays the same. The operations have ways to be compatible. If you go back to Frontier, almost all the clients still run Frontier level code. You just change a set of operations. What really changes with EOF is on the left. Instead of jump dest analysis, we're going to have EOF container validation. So legacy code will still have their jump dest operation, and the EOF will do something different with container validation, and they'll provide different data to the message loop. The jump dest says these are the valid jump tests. The container validation will provide, say, these are the entry points, the indexes for the various code sections, and this is where the data starts. But the message loop and opcode loop are still the same. Contracts still work the same. What's different, though, is there's some operations that are only valid for legacy EVM, and some operations that are only valid for EOF container EVM. And there's some operations we could add operations that are fine in both. Just a selection of operation changes. And I did put on here, how storage operates with it, how you get accounts, because that also is the same across all the different versions of across EOF and across legacy EVM. So I'll leave these slides. These will be in the slides. I put links on this page rather than diving into the code. But Geth, Nethermind, Besu, and EV1 each have slightly different ways to do their opcode loops. But based on the code that I've linked, you can see how they'll be able to handle getting these operations in differently. Geth uses a jump table. There's one per fork. They just overwrite the changes. Nethermind uses a gigantic switch statement, and they'll check versioning within each opcode and validity of the various steps within the loop. Besu does kind of a hybrid of the two. We have the jump table for most operations and some lesser used operations. For lesser used operations, we have a jump table, and for frequently used operations, it's in a switch. And we do opcode checking in the switch for push 0, and otherwise it's in the operation to check for it. EVM1 is C++, and of course, because it's C++, it uses macros, because that's why you would use C++. And they have some interesting things interacting with their data tables. It's some really interesting, it's very classic C++ code when you're looking at it. It works great, and they have their own way of handling it. So if you download the slides, you can click on these links, and you can see exactly in their code how they handle the operation loop. So with all that set up, with all that of why EOF, here are the 8 main feature categories of what is an EOF, of all the main EIPs that are in there. The first one is, of course, the EOF container itself. This is the definition of the container. The second one is static jumps. They're relative jumps in this case. And the columns on the right say whether it's container features or opcode features. If the opcode requires immediate, I didn't check container enabled. Although if you use immediate arguments, you have to be in an EOF container. Otherwise, we'll have the problems we saw earlier. Subroutines are a feature that it exploits the container and the opcodes. Code and data separation, of course, is container enabled. And here we get to some of the more esoteric requests of things we might want to break in the EVM in the future. And that, in my personal opinion, if we're going to break it, we should do it now, and we should break as much things as we may need to break. The first one is to remove code introspection capabilities. And that is so that when you write your code, you don't copy it into memory, and you can manipulate it and then post it out there. This is something that your iPhone does. It's got something called an NX bit. Except for the JavaScript just-in-time compiler provided by Apple, you can't write code on your iPhone and execute it. Your code and your data is fully separated. And that's what the code introspection is about, is preserving this code and data separation. The next one is to remove gas observability. This opens up space to do more interesting things with gas schedules without breaking contracts. And code and stack validation is another one, which is useful for transpiling EVM code either into just-in-time compiled code or to translate it to other systems like ZK systems. And finally, this is the most recent addition. We haven't firmed up everything on it. We just based off of some discussions on recent ACD calls. And that is to prepare for address space expansion. Right now, addresses are 160 bits. There's problems in just jumping up to 256 bits. So the first EIP, 3540, describes the object format. And here is a quick decomposition of what such a container might look like. So first, you got the magic bytes, EIP 3541, actually reserve the EF bytes. You can't deploy contracts that start with EF right now. It would take another EIP to make it legal. So we reserve space for our container formats. Every container format is going to start with EF. And in this case, it's going to be EF00 to say it's an EVM object format container. The version is 1, so we put versioning bytes in there. Hopefully, that'll just be there forever, and people will think the magic bytes are EF0001. But that's there in case we need to version it in the future. The next sections in the headers describes the other sections. So we got stack validation data, that's going to be 12 bytes. We have code sections. We are going to have 4 of them. We're going to have 3 of them, and they are 5, 1, and 5 bytes long. And then we have a subcontainer that's going to be 17 bytes long, and a data section that's going to be 17 bytes long. And then 0, 0, and that ends the header. So this is kind of the description of what we're going to see in the container. And then we have some metadata about the stacks. This is a part of another EIP. There's no inputs, no outputs because it's terminal. This is a -1. And the maximum stack height is 1. 1 stack input, 1 stack output, and maximum stack height of 1. No stack inputs, 2 stack outputs, maximum stack height of 2. And this matches the code. So we would push the 0. E3 is going to be the subroutine call to number 1, which is going to do E4, which is a return F. And then we stop. And this is unused code. So we're going to push the 0. We're going to push CODE to the stack. And then we're going to return F. And then we have a subcontainer. If we're going to be a factory and deploy other full EVFs, we have an option of putting that in here. So if you want to deploy a pool from your factory contract, you put the whole pool logic inside of your subcontainer rather than the data section. So here we define what that's going to be. And finally, we have the raw data section. This might include your validation metadata. This might be stuff you use within the code. It might be stuff other contracts might use for the code. But this is the raw data that is not used as execution code, but might be referred to it. Now, warning, this particular layout is probably going to fail some of the validation rules. We're talking about making sure that all code sections are used. So right now it would fail this. And I think there's a couple of other things that we're talking about making invalid in here. But this is just to demonstrate what a container might look like. The next EIP is static relative jumps. Basically, I described it in some of the intro slides. But as part of this, we're going to ban the old dynamic jump opcodes, as well as the PC opcodes. And this is going to make a lot of transpilation a lot easier because it is not possible to jump somewhere based on an arbitrary value. You could write some contracts that would take a destination off of call data and jump to random parts of the code. And those are very difficult for compilers to make sense of without, bloating the possibilities of every possible target that could be jumped from that position. So with static destinations, it really reduces the world size of these compilers. We also take the opportunity to introduce a vector jump. So if you have a number from 1 to 10, you have 10 different destinations. You can make that a lot more efficiently with the vector jump. EOF functions is EIP 4750. And this is kind of the logical progression, EIP 615, at least the subroutines part, and another EIP whose number escapes me, simple subroutines. But those code sections that I showed in the container are basically the subroutines you would call. And you can call F, call one of those functions, return F. You can also jump F. You can just jump to the container with no intention of returning. And this is very useful for tail recursion, which is something that a lot of compiler people get really excited about. It solves a lot of optimization problems when it comes to recursive versus iterative loops. Some of the stack height restrictions are enforced with the opcodes. You saw there was an encoding to say these subroutines expect 5 items on the stack, will return 3 items. That is also encoded into the container. So this EIP also talks about some features being added to the container, and it makes it possible to do subroutines. 663 is a long requested feature to increase the number of stack items you can duplicate and swap. This is under active development. It's using the immediate opcodes. And based on some of the talk we've been going through with one of the Viper compiler devs, it's probably the swap's going to evolve in something called an exchange, which is going to provide much more access to more stack things in a much more concise fashion. If we do something as simple as ordering which two items you are swapping. So swap 2.3 and swap 3.2, you only need swap 2.3. We can make swap 3.2 mean something completely different, which we're doing. The old dupe and swap instructions remain, even though that's 32, 30 different instructions we could reclaim. The current plan is not to deprecate those, but to leave those in place. EIP 7480 is another instruction. So we talked about code introspection capabilities. This is part one of that. This is to remove the read half, and this removes the capability of EOF contracts to read their own code and to read the code of other contracts. And to replace the functionality lost by that, we provide access to the data section. With data load, you can just load it into memory. Data load end, you can load a specific part directly onto the stack, get the data size, and copy your data. And now, as a side effect of this, legacy EVM will not be able to do the ext code calls into EOF contracts in order to preserve the code isolation from this EIP. The second half of remove code introspection is an EIP that's pending because it's currently up in the air for reasons you'll see as I describe it. But this removes create and create2 and replaces it with new create3, create4, and return contract. So if we can't read the code, then how do we write the code? Right now, create, you put your entire contract into system memory, and you tell the system, okay, run this code as though it's a new contract, or create this code from memory. To remove the code introspection, we need to be able to never see that code inside of EVM execution. So there's two main solutions to that. The first, well, there's three parts of the solution. One of the things is we need to be able to add code to the data section to do things like Solidity likes to have constant variables, and it'll put them into the code. So if we can put those in the data section, they can refer to them with data load end. But we need a way to get the contracts out there in general. So the second thing that's solved is how you create it within a container in a factory format. And that's what create3 does, is we would have the subcontainer within your container. And as a code factory, you would say, deploy this. This is something like if you have a swap pool and you need to deploy your pool code. The pool factory would have it in the EOF container and then just deploy it and optionally append some data into the data section. Create4 gets it from outside the EVM. And the initial proposal for create4 is going to be to get this from a new field in a new transaction type. You want to deploy a contract, you have a new create field in a create contract that includes the code that you're going to be deploying that is separate from stuff that is accessible from call data. And the return contract, as I mentioned, is a new return format that allows you to append data to the data section. So if you need to put the addresses of your the two tokens into your swap contract into your pool, you put those two in there as part of the data and deploy that so the contract can never have those changed. And these two EIPs together address the remove code introspection capability goal, making it so that basically the NX bit is enabled for Ethereum contracts, that you can't do just-in-time EVM shenanigans. As useful and as fun as they are, believe me, I think they're great. When it comes to creating secure, stable code, you really can't do that because the amount of opportunity to do nefarious things is just too great. So to remove the code introspection, you can solve a lot of problems with ZK compiling, a lot of problems with cross-compiling to just-in-time code. It's going to make it a lot simpler. And you can do a lot of these changes far, far in advance as far as compiling your contracts if we don't allow random contracts to show up. The next set of instructions addresses the remove gas observability goal. And the way to get around that is to not let contracts specify how much gas they're going to give to the next contract they call. So we would ban the gas operation to see how much gas you have left. By necessity, remove the 4 current call codes, call operations: call, static call, delegate call, and call code. Call code's not coming back. No matter if 769 passes or not and gets into the first revision, we are going to ban call code. Nobody uses it. I have kept receipts on a lot of the current execution. So that's a safe one to get rid of. So we would replace 3 of those calls with, right now they're called call 2. We'll probably get a better name to these, like light call or gas-free call, or we don't know what the name's going to be. We'll workshop that and get it later. But what we remove from these calls is we remove 3 stack operands. First, remove the gas stack operand. And second is to remove the output location stack in memory. There's a lot of times where you never use the memory values for this. And there's ways to get it to return data via existing operations that don't get into memory. So your calls are going to be 3 or 4 stack items, which will also have a huge impact on making things a lot smaller in code. Now, what's neat about these operations is these don't depend on immediate arguments. We can make these available to legacy EVM. If you're okay passing all your remaining gas, which is the default in Solidity right now, then this will be just fine. So, one side effect of this is if you're in an EOF only system, you cannot, wedge yourself with some of these schedule changes. And for the most part, you'll just be able to send more gas if the gas schedule goes up. It's not a perfect fix, but it fixes a lot of things. And this, if we're breaking things, this is one that people have talked about for a long time. I think we should add it to the list. And I've added it in a way that if we get it wrong, we can always restore the gas and the 3 call, static call and delegate call operations to restore gas observability to EOF if that's necessary. EOF code validation is EIP 3670. This says that all code inside of an EOF code section must actually be used. We can't have dead code. Your jump destinations must all be valid. You must reference code sections that exist. You must reference subcontainers that actually exist. So what this EIP is saying is your code must actually, some way, somehow, execute and execute it validly. And so this solves a lot of problems that we would check for at runtime and executing these operations to make things like making sure that the stack doesn't fall down. We don't, pull. There's enough items on the stack so we don't pull too many in underflow. Make sure that we have, where we're going is going to be fine, so we don't have to check that at runtime. So a lot of the checks that these clients do at runtime with code validation, we can just get rid of, knowing that the code has been validated and some of the assumptions are safe and have been validated ahead of time, and that'll speed up all the execution loops. Another nice thing this does is it also makes adding future opcodes a lot easier in EOF. If we validate that those opcodes are not in use in any EOF contract, introducing this opcode is going to be a lot easier because we aren't going to have to worry about pre-existing contracts that might, have that in leftover excess data that might possibly be accessible. So this simplifies a whole lot of features, compatible evolution of EOF. 5450 is kind of the complement to the previous 3670, and that's stack validation. And so what we're doing in this is we're analyzing each of the operations and making sure that stack cannot grow out of bounds, that the stack operates within a fixed range. And when we do this, we can actually get rid of a lot of the stack validation rules and the stack validation checks as we execute it. We only have to check for stack size when we jump between code sections, but we're executing the operations within a code section. We can just presume that there's going to be enough stack because we've proven that we can only use the stack that's available. Now, one of the interesting side effects that the compiler people are going to get excited about is this makes it easier to transpile from a stack-based system to a register-based system. It's a lot easier to prove that your code is operating properly in a register-based system. And I think like 40% of opcodes out there are basically swapping data around to make it available for the next operation. And this is also good for ZK code and transpiling EF code to other targets beyond just the whole register versus stack. There's a lot of other great things that make this very easy to make much more efficient and in some cases linear time across compilers to go to other systems, which is good news for just-in-time encoding of EVM. One EIP that we don't have a number for yet, that we've only been talking about recently, is what I'm calling prepare for address space expansion. There's been some talk of this with things like Verkle tree needing to access, more space so we could encode possibly. One proposal for this was to encode, what era these accounts were made in and tracking that in the high level of the address space. We could track about whether things have been updated and paid for and store metadata in these. And, there's other places you might want to use the address space expansion. And one of the reasons it got shot down has to do with the way that opcodes deal with addresses. The 9 operations that take addresses as stack argument, they only take 160 bits. Balance, self-destruct, ext code series, and all the call operations. If you pass in 256 bits of data, it's only going to read the first 160. So any proposal that's come before to do address space expansion is running into the problem that we literally make it impossible to do it. In EOF, we can break this rule, and we can do it in a compatible way that won't break other contracts. We can't just turn this on because there are a few situations where like packed ABI encodings depend on the top 96 bits being stripped away. And also copying these values straight from call data. You might put bogus data in what would normally be 0. So in some contracts, they rely on this call data protection. So you can't put the extra data in your ABI call and put this bogus data in there. It would be stripped away by the opcodes. And then now it's going to show up. And what's most importantly, however, is that these are validated in reference tests. All of these operations, there's a reference test that's linked in the slides that verifies that we strip the data. And so finally, before we can do any address space expansion discussion, we need to have the space preserved. We could do it without EOF. We could just introduce an entire new series of call operations and ext code and balance. We could drop in 9 new operations that are preserving of this. But I think doing it with an EOF makes more sense, and it consumes less opcode space. I think it's more rational. So that's my pitch for that. This, we're still working on workshopping exactly the details for this. So a summary of those past 8 slides of all of the opcodes. There's a list of opcodes that we're replacing. We're replacing 9 different opcodes with EOF equivalents. We're removing 7 opcodes, and we're adding 9 opcodes. So there's only a net gain of 2 opcodes available to the VM. But some of these need to be adjusted to what's being handled with an EOF and the EVM. So functionality-wise, we're only really adding 2 to the instruction sets compilers need to worry about. Now, of course, these 3 are special. These actually could be exposed to legacy EVM without any complication. So in some ways, you could say we're only -1, depending upon the way you look at it. So that's my quick tour of all the various EIPs that go in here. If you have questions, want to participate in the process, if you have concerns, if you just want to talk about EOF, the single best place to do that right now is the EVM channel on the Ethereum R&D Discord. If you're looking at the slides, you can just click on this, or you can scan the QR code that should take you to an invite. And if we don't have, we might be able to put a better invite in the video link if you're watching this. So check the video link to see for a link for this. I don't know how good my invite code is, how long it's going to be good for. But again, if you have any questions about this, the best place, we're all on the EVM channel. We love input. It's because of this input why some of these things have changed in some of the list above from where we were in January. So, we absolutely value all the input that we get.
Thank you so much for the presentation and the in-depth covering of history, background, and individual proposals. I was struck by the list of unimplemented and unadopted proposals. It's huge. EVM execution architecture and comparison with the existing EVM was definitely helpful. I will perhaps invite the authors of each EIP, client teams, and you to explain EIPs when selected for the upgrade. For now, I think this was beautiful overview, and now we have like what people can expect out of this process, and we can also think of which all EIPs are important to be moving forward as soon as possible. So yeah, thank you so much for all the presentation. My first question is with respect to smart contract developers and other users. You have already tried to explain part of it during the presentation, but just to summarize, if you can maybe talk about, will it have an impact on the security of smart contracts or affect gas cost for executing smart contracts on the Ethereum network?
So I didn't list some of the on-the-bubble features, such as jump FI and ext code copy. But based on feedback from Solidity and Viper, if we get the code operations mixed, contracts will actually be smaller, even though we're adding a header section and some metadata to it. The growth rate, the net change in some of the operations, in typical cases, you'll see smaller contracts. A lot of this comes from getting rid of the jump test operation. I think that's something I glossed over on the slides. We're changing into a no-op. With our jumps, you don't need a jump test, and that's sometimes 20% of code. So if we don't have those operations, right there, you're getting immediate savings. Some of the stuff that we're making available for stack manipulations, you can do it in 1 opcode rather than a series of 2 or 3 opcodes. That's going to save space. As far as security, I don't think it's going to make security any worse. It might make security tooling a little bit easier. If the security tooling can look into the code and have assurances about the stack validation, or at least not assurances, but to know some of the limits based on stack validation and code validation, I think it can do richer and more exciting analyses of the EVM level stuff. I'd like to think that possibly this might have helped us find the Viper bug easier if we knew what these things, what these calling conventions were. It would make it easier to access the code. Versus if you're trying to access EVM code right now, you're never sure where the data section starts, unless you're following specific versions of Solidity. And even older versions of Solidity have different conventions about how they separate the data and the code. It's hard to tell where the code is and where this code that's never executed is. And then there's even some weird cases. If you're taking a jump, if you write poorly, you could take a jump desk from call data, and your metadata might have a jump desk, and you could possibly use that as some strange attacks. Some of those esoteric security approaches are just invalid now. So in some ways, it probably improves the security. But I think that what it does to the tooling to automatically analyze your contracts, it should make things better just by the container format alone. We don't even need stack validation and code validation, although those would make it a lot better. Just the container alone is going to make it a lot easier to validate with automated tooling.
That's comforting. I mean, it's always a burning question coming up from DApp developers community, like what is in it for them when we are making any improvement changes to Ethereum. In the presentation, you talked about compatible and non-compatible changes. I'm wondering if there are any backward compatibility concern, and if so, how will they be addressed?
So one backward compatibility concern comes in the self-destruct operation, and that imposed one of the rules. I did put in, there was one slide with some random things on there that I took out of this form of the presentation, but you cannot delegate call from EOF into legacy code. And the reason is, in EOF, we ban self-destruct. And if you delegate call into a contract that does self-destruct, all of a sudden you've introduced self-destruct back into EOF. So as far as composability, you can call and static call all other operations, but delegate call, EOF can only delegate call EOF, and legacy can only delegate, well, legacy could delegate call into EOF if it wanted, but you just can't get back out. Another compatibility issue is that only legacy code can create legacy contracts, and only EOF code can create EOF contracts. And that has to do with the validation barriers. So there is, a little bit, but that's, working within, like when you got like a whole constellation of smart contracts working together. And the smart contract authors, I mean, it's just, you're going to be deploying your own contracts. You're going to set your flag and you're going to say, deploy it in EOF mode. So it's going to be mostly self-contained as far as these compatibility issues. So it's not going to be, I don't expect huge levels. But as far as that slide with, breaking and non-breaking compatibility, I think the big point I wanted to make there is that the reason I'm most in favor is there's multiple formulations of how EOF could ship. There was small EOF, there was big EOF, and then there's something now called Mega EOF. And Mega EOF includes literally everything on that list. Basically, you go to the candy store and you get everything you want. So if we do it that way, we only have to introduce one EOF validator into the system, versus if we do multiple steps, if we do EOF v1 and EOF v2 and EOF v3, all three of those versions of the validators now have to live in every version of every client that comes out forever. So that's one of my motivations in trying to limit the number of versions that we have. And based on some of the thinking I've done about how smart contracts will work, I think that list, if we get rid of code introspection and we get rid of the whole gas issue, the whole gas observability, I think that possibly puts us in a position where this is the only time we'll have to do a new version of EOF, a new container format. All the changes we would do, unless we start, there's other reasons we might want to do it. We could run out of opcodes when we have to reclaim push and dupe and swap. Those are some things that might force us to do it. But it gets us 5-10 years down the road. And I think there's, optimistically, it could get us all the way down the road for the entire life of Ethereum. If we do all these breaks at once, we'll only have to do it once, and it increases the odds. But if we do only some of the things on the list, there are going to be people forever pushing to get the rest of the list done, which means a second set of EOF changes. That might be the appropriate thing to do security-wise. It might be a trade-off we're willing to take. And that's some of the things we're going to discuss at Istanbul. That's a solution I'm willing to accept, But if I had to pick one of them, it'd be ship all of them. And if I had to pick second chance, it would be ship whatever we can get. So that's where why I put those slides in there and talked about the evolution, because we can evolve compatibly if we do all our breaks at one time.
That's pretty interesting. Yes, I was about to ask this question, like from the last ACDE meeting, it sounds like some of the execution clients are not yet in camp of EOF for them. And for many others, it would be interesting to learn about what are the proposed shipment plans, like big, small, and mega, as you shared. Hopefully, we'll get to know more about this after the meet at Istanbul.
Yeah, we had implementations of big EOF across all the major clients. Aragon can take Geth, no problem. That's not the things that they're changing with. And we've had Nethermind and Geth implementers on the calls. I think the engineers are on board with it, but I don't know if the CL's on board with it. Sure doesn't sound like security is fully on board with it yet. I'm hoping that's just because they don't understand what it really is. And I'm hoping that, part of that is just from their previous experience with EWAS, and we were proposing, ripping out the entire EVM and running a parallel WASM VM in parallel, or doing some translations with it. So I'm hoping that that's where they're coming from. So I'm hoping it's an educational thing, but there may be some other security things. There's security issues we don't talk about on ACD calls. There may be some security things I'm not aware of that they may be concerned about. So hopefully when we get together in Istanbul, we'll be able to hammer out what a shipment plan for this looks like.
Sounds good. So you briefly mentioned about the client implementation, and you mentioned that it is for big changes like big shipping. So this is, again, I'm assuming is going to be a limited list of proposals, not as all as it is listed there in Mega EOF specs. Is that correct?
I'm going to advocate for Mega. There's probably going to be some things I'm going to have to give up on, and I'm okay with that. Yeah, I think the container format itself is a win, but I don't think it's a big enough win. I think there's big wins we could get just by adding the code validation, the stack validation. And I know there are some big names in Ethereum that are really excited about the potential of getting rid of code observability. So it's kind of interesting to hear some of the bigger names on ACD. We're getting, in some cases, contradictory feedback. It's like, oh, we need to break more things. We need to break code observability. And then another big name says, oh, no, we can't do too much. That's going to be too much. We can never do that much in one step. So I think that's why it's good we're getting together in Istanbul, so we can get all these big names for asking for contradictory things to see what's really important, and to get a plan for getting to where I would like the EVM to be.
It gives a lot of confidence to know that at least there are implementation ongoing. I wonder if there is any plan to have a dedicated testnets, just like we have it for 4844. Do you have by any chance timeline for EOF devnets?
No, we don't. I think what we need to do, so as far on the EOF call, we're not really accepting any new features in EOF. We're just hammering out the existing features, the exact semantics, and possibly pairing some of them out to make sure that it's of a size suitable for ACD. So once we figure that out, we'll set up a devnet. There was a Shandong testnet that was run back for Mega EOF back in the end of last year. We don't have any concrete plans right now, but I'll guarantee you that there's going to be testnets out there that test this. That's just the way hard forks happen nowadays. There's going to be a testnet that's going to have this version submitted. And the point is people try and submit all their contracts to try and break clients and do things. I think another very important aspect of the testing approach, though, is devnets, while they're very valuable for consensus layer changes when you're talking about the emergent characteristics of network behavior, the EVM code is a lot easier to isolate, and we don't need to have multiple clients involved in a network trying to break it. So there's some tools that some differential fuzzing tools have been written by a number of researchers, and they've been very good at finding out the differences. And they've kind of shifted focus to now looking for performance issues in some of these clients and sending the information to the clients, say, hey, this is a bit slower than the other stuff that we expected. Maybe you should look at that. Got some good feedback from the differential fuzzers. So the differential fuzzers, I think, are going to be just as valuable as any shadow fork or side networks, and making sure that the stuff is compatible and the stuff isn't going to break consensus. But another unsung feature of the devnets is people can start deploying their contracts and start judging the usability. And that's we're going to need the devnets are going to be important when Solidity and Viper start releasing beta builds that would support whatever EOF looks like for theirs. They have working code and branches supporting most of the features in various formats. But once we finalize, this is what this spec looked like, and this is the parameters that we're supporting it to, then they can start, deploying some of these to testnets. And I think a really exciting thing to do would be to take, the whole history of all the contracts ever written and deployed, tweak the pragma lines, say, hey, use this version of Solidity and see if it'll compile it. Make sure it's, the issues aren't just, that we're using features that were deprecated and removed, but to see if it still compiles and see if it still functions. And I think that's also another exciting opportunity that like a dedicated testnet would have. So there's no formal plans. We need to get there defining, saying this is exactly what the first version of EOF is going to contain, no more, no less. We thought we've shut the door before. We've been wrong. So hopefully we'll get there. And that's why you do testnets, to make sure that all of your assumptions are valid and everything is true. And that's part of what, took some of these other hard fork releases, why some of them needed to be walked back, is because you make new discoveries. So, when you run a testnet and you discover something, that's not a failure. That's the testnet working as expected.
Great. Thank you so much for explaining that in detail. My next question is with respect to Ethereum long-term vision. How does this EOF changes align with the long-term vision and goal of Ethereum how will this change impact the overall performance and scalability of the Ethereum network? At the same time, why do you think some of the execution client devs are not supporting EVM changes, given the list of EIPs are important to the execution chain?
So I think one of the reasons why some execution client devs are hesitant about this is they just look at the sheer size of the change list. That is enough to give anyone pause. And to just, go in that and plow in and ship everything based on someone's word for it is not a responsible thing to do. So that being their initial reaction, I think is healthy for them to be skeptical of it until it's proven its way. And I think it's just the size is where I think a lot of people are resisting to it. I think there's some that would question whether we even need a container format at all. What we have is working. It's not the best, but people have made it work. And there's some argument for taking something and then just freezing it and never changing it again, except in very small calculable ways. And there's, a lot of security aspects there. But as far as the long-term vision, I think it's very risky to freeze the EVM as it is today. It's kind of one of the moats that Ethereum has around itself. What links together Ethereum mainnet, Optimism, Arbitrum, Stilo, Avalanche, Binance Smart Chain. What threads all these various different not unrelated ecosystems, but they're all related with these all different large ecosystems together is they all run EVM smart contract code. And this is the thread across the vast majority of smart contract systems. If we lock it in something that does not allow for healthy growth of new features like being able to just-in-time compile, being able to cross-compile, being able to take it into different formulations. My concern is that these chains will start drifting away and use different scattered VMs for their features. There's going to be a lot more Solana VMs. There's going to be a lot more of whatever Michelin, I can't remember how to pronounce it, of what Tezos uses. There's going to be a lot more fragmentation amongst the various systems out there. And I think, Ethereum defining the industry standard format is good for Ethereum. And to continue to define the standard format and taking the lead, I think is going to make Ethereum stronger. It's the moat. And letting this feature slip away is filling in the moat and inviting competitions in ways that might not be, it might be good for the industry as a whole, but it might not be best for, Ethereum as the dominant chain. So my long-term vision for EOF is to get it in a position where we can do these evolutions with a minimum of fuss, because we're going to have to break things to do some of these features. And I think the container format is the safest and most direct way to break these while still remaining compatible with the legacy systems.
That is interesting. Thank you for sharing.
Mm-hmm.
All right. Now, you just mentioned about other chains, other smart contract chains using EVM. I am not sure if any such metrics already exist, but if not, what measures will be put in place to monitor the impact of these changes on the Ethereum network users to begin with?
So one thing we could look at is deployment of new smart contracts if they're using EOF or not. One of this long-term visions is that Ethereum might move to allowing only EOF contracts to be contributed, to be deployed. So maybe 1 or 2 years after EOF is active and gain a lot of engagement, the word might go out that starting at this hard fork, we're not going to accept new contracts that are legacy. So what that would allow, and kind of diverging from the question you asked to something else that I thought about, but if these metrics are good and there's a lot of adoption, then that allows us to basically close the door on legacy. When we close the door on legacy, that allows us, once we're no longer deploying legacy contracts and only letting factories deploy contracts, that allows us to go back and analyze, what contracts are out there and potentially reformulate those so that they behave the same, but that we could then, rather than requiring people to run an EVM, maybe we could enshrine one of the ZK proof systems in there, and we could create a ZK proof of the old contracts, and the new contracts would come in a compatible ZK proof. That's, that's some of the things it enables. So as far as judging the success of the deployment of EOF, we want to see the number of new contracts that are being deployed. We want to see new blockchains adopting it, old blockchains. We want to see rollups adopting it, which, if it's integrated into the main clients, it's going to be easier to have EOF. Base's got an implementation, then Linnea can, bring in EOF really easily. If Get's got an implementation, Arbitrum and Optimism can just, turn it on really easily. A lot of these alt layer 1 chains that are Geth derivatives, they can just take the VM code and they can adopt in their own alt layer 1. I mean, that's the plan of record for Hedera. We use the EVM from Besu as a library and use it with a minimum of integrations. So that's one of the advantages of getting in the core clients. Netherminds, whatever clients are using Netherminds to run their rollups or wherever Nethermind's putting it in, if they have a compatible version as well, it just rolls downstream, and everyone that's using these projects can just implement it. So, another measure is to see who else is using it, what other systems are using EOF. We don't want to ship a white elephant. And I think that's one of the reasons why big EOF got pulled out of Shanghai, is there were some issues with adding data to the data section that made it impossible for Solidity to use like it wanted to. And it would have been a white elephant like the Blake 2B precompile. So we don't want to ship a white elephant. So I think that's a good instinct, is we need to find ways to judge the success of this.
I hope someday someone maybe come up with Dune Analytics to maybe pull out this data and we get to know about how many EOF contracts are there. So yeah, that could be helpful. My next question is about the alternatives. Are there any alternatives to EOF Mega Spec that have been considered? And if so, what are their advantages and disadvantages? Maybe if you could talk about EOF Mega Specs, why we chose to move ahead with that.
Okay. One alternative that was considered and dismissed was just replacing the whole system with WASM. They did a lot of research into it. There were a lot of performance issues. They almost had a solution to performance issues, but the appetite for running two systems just isn't there. So that's one of the solutions that was put out. A couple of, it was EOF, that list of unimplemented EOF, there were a couple of other solutions that would have addressed some of this within the EVM. Rather than making the containers format mandatory, of putting markers in the code that would allow it to basically opt into the container and function the same. Like there was a begin data opcode that everything before it had to be considered valid if it shows up in there, which presents some problems. What if that opcode was in someone's metadata section for it wouldn't necessarily work. There's also a consideration of putting account versions, and if you're when you deploy your account for the first time, it gets the current version of the system. And if you're version 2, you can't do certain things, but version 1 can do other things. That alternative, I think, was rejected because the metadata is not in the container. So what I like about the container format, that some of these alternatives of just putting these markers in code, let's do subcontainers in the code without having to have the immediate arguments. But the advantage I like about the container format is when you opt in, you get a whole lot of features for free, and you get a lot of the validation, and it's self-contained, and it's a compatible forward evolution of it. And it looks the same. It can live in the same EVM bytecode. It uses all the same opcode semantics that the existing legacy VM uses. But I think probably the biggest thing that the use of immediates, I think, also has a lot of code size saving opportunities there. So a lot of the other systems would have had very large markers and wouldn't be able to address some of the size issues that could be seen. I mean, we're limited to 24K per contract, and that's a huge issue for a lot of these developers. If they could squeeze out another 5-10% out of these bytes, there's a lot of things that they would love to do. I mean, really, they want a limited bytecode, which is something that might be worth analyzing. But it's if we can get more data more tighter, especially if they're going to be paying for it with Ferkel trees and execution proofs, smaller code's always better. It's hard to say that it's not.
Awesome. That's a lot to take in, but I think it's useful especially for developers community, that there are a lot of improvement lined up, and we can perhaps share our feedback to show which one is urgent, which one is important, and which one community wants to have it in the next upgrade. Well, we went a little bit over time, Danno.
It's a lot of EIPs.
Yeah, a lot of EIPs for consideration. So I think it would be really interesting to get feedbacks on what people think is of most importance and get that pushed, if not all, in the next upgrade. At this time, Danno, if you have got any message to the Ethereum community.
I think the best solution would be to do this Mega EOF as soon as possible, but it's not the only option that I think is on the table. We should be able to pair stuff out if we need to. But I think for the maximum, if we're going to break stuff, we should, measure well and break as much as possible in one go rather than having to go back in multiple steps. So that's why my pitch for EOF is everything. I think there's functional utility of this, of smaller formulations of it, but the more you add, it's like you get, the whole is greater than the sum of the parts in a lot of these features. So that's why I'm really excited about the potential of shipping all these features. but it doesn't have to be all of them. It could be some of them.
Absolutely. I was thinking that this Danco upgrade is going to be one of the upgrades which has the most EIPs. If we have to ship Prague with all of EOF, it's going to be a record on its own.
Mm-hmm.
All right. Danno Ferrin, I appreciate you taking out time to provide an overview of EOF proposals and specs. We look forward to seeing proposals moving along the network upgrade process and being deployed on the mainnet in 2024. On this note, thank you to all our YouTube viewers for watching and ECH podcast subscribers for listening and following this special episode on EVM. Check out the link in the description to learn more about this upgrade. Should you have any question on this or any other topic, let us know at eCatHerders Discord. Next week, we'll be back with another interesting talk. Till then, keep sharing your love with Ethereum cat herders. Thank you so much.